Hey everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Ooh, nice. People ask me why I always check this and sometimes I go too quickly, but you can see on the the other side, that there's a feeling lucky button, and if you click on it, you get 10 coins. Yay. So yeah, so just a heads up. Today's problem is jump game. Yeah, also hope everyone just having a big good jump for your holidays and stuff like that. Yeah, hope you had a, I don't know, I got nothing. Puns are hard. That wasn't even that good of a pun though. No excuse. Okay, anyway, today's problem is 55 jump game. So you give an index, integer array nums, and you're at the first index and your maximum jump length at that position. Return true if you can reach the last one, force it otherwise. So there are kind of a couple of ways you can think about how this can be done. One way to do it is with dynamic programming. Basically, the idea is that if you can go to 2, then that means that, well, then you could just go to 2, right? And then you try to, go maximum that way. But of course, the thing with doing it that way is that you are going to get duplicate indexes, but that's okay. I think if you cache, it'll be okay. But yeah, if you cache on your memorization or dynamic programming, or if you go dynamic programming, yeah, that'll be fine. And of course, it's 10 to the 4th, so you have to be careful about not n square. But yeah, but each of these only goes to one place anyway, so that should be okay. And you only need to return true. But the other way to do it is kind of, you can think about it in a number of ways, but it's also dynamic programming. Because the other thing is also that it's not just 2 to the 1, it's 2 to the 3 to the 1, right? So that means that we can just kind of one by one try to figure out what is the farthest that we can go. So maybe that's the way I would do it. So the farthest we can go is at index 0 in the beginning. And then for index x in enumerate nums, I guess maybe jump, J for jump maybe. Okay, so if index is less than or equal to furthest, that means that we are able to jump from here. Then the new furthest that we can go is equal to either whatever plus j, I think. Yeah, right. And then that's pretty much it. And then we just return whether the farthest is greater than or equal to the length of the nums. Do I have to go to the last one or outside the last one? Okay, so then -1. And I think that's pretty much it. So let's give it a submit. Cool. Oh, 1,000 days. 4 digits to my days. I guess it'll be a while until that happens. I guess I should celebrate. Let me take a screenshot just for... Oh no, it went away. Well, okay, well, no screenshot from there. At least maybe I'll have to take one from my video or something. But yeah, this is going to be linear time, constant space, as you can see. The idea here is just so that, because we are it's kind of like you see it as 3 lines of code, so it looks easier than it is, to be honest. But because this is also greedy in a way, and the proof is kind of, you have to wrap your head around it. It takes some practice. But the idea here is that for every place you can go, up to that point, you want to be able to kind of just check all the things to check anyway. So then instead of, another way of doing it may be that, like, for k in range of index, right? Or sorry, index plus j or something out of a jump, right? And then you do some jump count. But then another way to think about that is just, instead of doing a max from here, you can set something like, go visit of k, or index plus k is equal to true. Maybe that's another way of thinking about it. And then if you think about it from here, then the way that you would imagine is just you want the intersection of all these segments, right? Because what do these things really mean when we kind of do it this way? Well, the way is just kind of like, okay, well, another way of thinking about it is instead of maybe 2, 3, 1, 1, 4, the way to think about it is now you have a 0 to 2 line segment, and then maybe a 1 to 4, 2 to 3, 3 to 4, and then I guess 4 is just, it goes out of bounds, but you get the idea. And then it's just the intersection of these line segments, and this kind of allow us to kind of do it in a different way. So maybe this is a different visualization as well, because you start with, with these things. Like I said, linear time, constant space. That's what I have with this one. Let me know what you think. 1,000 prompts today, so yay. Yeah, that's what I have. And also, like, I'll have another video talking about advent of code maybe. But yeah, enjoy your holidays. I'll see you soon. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.